Good morning to viewers. This is Dr. Parvathalu Kalakunda. Today, I am going to speak about importance of physics, in which I'm going to talk about basic laws of physics. Basically, I'm going to talk about Newtonian mechanics. Uh, we all know that everyone feels physics is a tough, but it's really easy if you know it, if you understand it. uh, the physics is such a lovely subject, uh, the only thing you should know the basics of physics. So once you know the basics of physics, you can handle any type of problem. The first thing you have to, appreciate the laws. Actually, what are the laws? Actually, I mean, how to use these laws. Wherever you need to use. Actually, when you're solving the problem, you definitely need these laws, and you need to read the problems. I mean, everyone, the physics, they see the physics like, so scared, but not like that. I mean, you should treat the physics like, it's a day-to-day activity. It's not a different, right? Every activity you can see the physics. I mean, whatever you do the work in day-to-day activity, when you wake up, when you walk when you cook, or when you do exercise, every activity you can clearly see the physics. And let me talk about today basic laws. I mean, when I say basic laws, you definitely remember the Newton, right? What is actually, who is the Newton? Newton is such a great scientist. He proposed the three main laws. The first law is inertia, law of inertia. What is that actually? What it indicates, the physics, definitely, the inertia play a very important role in physics. uh, in every body is to be in rest or uniform motion. Every body in a uniform motion or to be in rest until there is a external force act on it. Which means what? You are not applying any force on it. You are not giving any type of external force on it. You are not giving any unbalanced force on it. Which means the body should be at rest or uniform motion. So this is the first law of Newton. I mean, you have a lot of applications of this law. The first, let us give me one example about inertia. What is inertia? Inertia is nothing but like, uh, the movement that you have. Like, what it measure inertia? Mass is the one which measures the inertia. Suppose, let me give, what are the types of inertia? Uh, there are three types actually. When a body in rest, we talk about one type of inertia, inertia of rest. When a body is in motion, we talk about one type of inertia, motion inertia. When a body changes direction, we talk about inertia in direction. I mean, here, let me give the first example when a body in rest. Suppose you are standing in a bus, the bus in a rest position. Okay, you are standing in a bus, the bus in a rest position. What happened now? Tell me. So now the bird, the drivers immediately start the bus. The driver, you don't, focus that. So the driver immediately started the bus, and you are standing and thinking something else. So what happened now? Do you feel something? Do you change your mass something? Do you, here in the case, see, you are standing on the surface of the bus. When driver start the bus, your legs get a motion. Your legs get a motion. Your body is still in the rest position. So it's a rest position, right? So your body falls back, right? Because your body is still in the rest position, whereas legs got a motion. So this is the inertia of rest. So the second type, we'll talk about now second type of inertia. So the other way now. So now the you are standing in the bus is in the motion, right? The bus is in the motion, you are standing in the bus. Suddenly the bus driver stopped the bus. What happened? In that case, the legs motion stopped. The legs got stuck. So now your body is still in the motion, right? Your body is still in the motion. So it takes time to get into rest. So in that case, your body falls frontward direction, right? Why? Because your legs completely stopped because the legs are contacted with the surface of the bus. When bus stops, definitely what happened? The entire body in the motion that time. So legs suddenly stopped. So you falls back. You falls front direction. This is the inertia in motion. The other inertia in direction. Suppose you know that, right? You are standing in the bus. The bus is in the motion. Suddenly, the bus driver changes the direction of the bus. In that case, what happened? Again, it's the same thing because you are moving in the forward direction. Suddenly, the driver changes its direction. In that case, your body is still in the same direction. So when you turn this side, your body also change. It doesn't take immediately change direction. Okay, so this kind of inertia is motion in direction. Okay, so coming to the second law of Newton. So what is the indication of second law? Because these three laws play very important role in physics, basic mechanics, Newtonian mechanics. The second law of Newton state that completely he explained about the force. I mean, without force, there is nothing exists in the physics, right? First thing we should understand the force. What is a force? When I talk about the force, if you don't apply force, there is nothing, right? So the force is what actually? I mean, there are many types of force in the universe. Let me talk about the basic forces exist in the universe. You know that gravitational force. Other one is electromagnetic force. Third one is nuclear force, strong nuclear force, and weak nuclear force. Now the question, how these forces exist? I mean, how the forces came actually into play. You know that the first gravitational force, there is an exchange of gravitons. I mean, we know that we cannot see this particle. There is a particle called graviton particles. Light ray is electromagnetic wave, right? So electromagnetic waves consist of photons, Phon, photons. The exchange of photons, you have the electromagnetic forces. I mean, you can also define another way. Whenever the charge moving with as respect to the time, or whenever the charge is accelerating, you have the electromagnetic force too. So moving into the strong nuclear force. What is a strong nuclear force? It's a very important force that we have to discuss, right? So, nuclear force is the force which is in the nucleus of atom. But how it comes? It exchange of mesons, like a proton, neutron, right? So, exchange of mesons, you have the strong nuclear force. And there's another type of force is weak nuclear force. And this force comes from exchange of bosons. I'm gonna give a talk on these later. When I talk about the nuclear physics, definitely we have to talk about the nuclear forces, strong nuclear force, weak nuclear force. And now talk about which force is the strongest force in the nature. Definitely, the nuclear strong force is the one strongest force. Then weak nuclear force, then followed by electromagnetic force, then followed by gravitational force. Right. Then moving into the, so now we talk about the forces. And what is the force? We didn't even talk. I mean, how it comes actually. Yes, exchange of particle, it comes. But what is the definition of force? It's really very simple. When I apply the force on any object, right? I mean, you can think about when I apply a force, you can see, you know, there is a, F is equals to ma, right? F is equal to ma. What is this? You can also write this as dp by dt, right? What is this actually? You know, you can see clearly here, force is product of mass and acceleration. And here you can see it's a rate of change of linear momentum. So to talk about force, definitely what we need to talk about the P. What is the P actually? P is nothing but it's a product of mass and velocity. Linear momentum is a momentum, it's a product of, it is a product of mass times velocity. I mean, you guys know that velocity, right? It's a rate of change of displacement, change of momentum. So momentum is changing with respect to time. So that is actually definition of force. So force is a, you can get this from here. What you need to do, you have to, so dp by dt is equals to, where p is what? So definitely what happened? So mass does not change. So dp by dt is equals to mass, you can pull it out, it dv by dt. So in this case, so velocity changing with respect to time. So now the force is basically product of mass times dv by dt, which means dv by dt is what? Acceleration. So you can write down m into a. So now the force definition is, it's a rate of change of momentum. Still, I don't understand. I mean, you should, we should, I mean, I have to make the student should understand this. I mean, if I teach this rate of change of movement, what is this? Movement. What is movement actually? When I give a kick, there should be change in momentum of an object, right? So if I take object, let us say, so if I take this one, I apply the force, there could be some changes here, right? So when I apply the force on any object, there is a change in momentum. So it's basically rate of change of momentum is called force. So now we understood force is nothing but, like, there should be some change when you, if the force is zero, definitely there is no change in momentum. So if momentum is does not changing with respect to time, so force is equal to zero. So whenever force is zero, there is no momentum. Whenever momentum is zero, there is a force equal to zero. So in the absence of external force, if there is no force acting on the system, which means the force is zero. So in that case, what happened? Tell me. There is no momentum change. dp equal to zero. dp is equal to zero. What is dp? dp means it's a change in momentum. dp means change in momentum is zero. The momentum is equal to final momentum. Initial momentum is equal to. Let me give one example. If I fire a bullet, what happened? The bullet go in forward direction. The gun kick you back. Why? Why it's kick you back? Definitely to satisfy the conservation of movement, linear momentum. What is a conservation word? It does not change basically. Momentum does not change. So whatever the momentum in forward direction, when bullet fired, the same momentum should balance it. The momentum should be same. So momentum is conserved. So now the net force is zero. There is no force acting on the system. Only these two forces balanced. The momentum does not change. Right. So now we understood here force we defined, and there is one more term also we have defined, that is conservation of linear momentum, which is the conservation of linear momentum stated that in the absence of external force, the change in momentum of the system is equal to zero. In the absence of external force, which means the momentum does not change. Okay, so let's move on to the another term called impulse. Impulse is such a good concept to understand. Impulse, you can understand that it's kind of force. Don't think about it. So you can think about it. F into F into T. So what is this? So basically, F into T is nothing but it's a product of force and time. So product of what do you get it from here? There are a lot of applications there. The amount of, suppose you are let us I ask the two persons to jump from the building to the surface of the earth. So one case, there is a the surface is basically very rough, very strong. The other case, the surface is filled with the sand. So one person is jumping directly onto the hard surface. The other person is jumping on the sand surface. So I asked the two persons to jump at the same time. Who get hurt here? The person who jump on the hard surface. Why? Because the amount of force act on a person in a short duration period is higher. The force is much, much higher in a short duration of time. The person on the hard surface. Whereas the person who jumps on the sand surface, what happened? The time increases, right? He jump onto the sand It takes time to reach on the surface of Earth. The longer time, shorter force. If the time is increased, the force is shorter. So in that case, you get impulse less. Another example, let me give. You guys, I think you guys understood this, right? If the time is increased, the force is low. If the time is low, force is higher. This is directly proportional. Impulse is directly proportional to the force and time. So now another example is the cricket. I mean, you guys have love the when I talk about cricket, you know the bowlers, batsmen, right? When a batsman hit the ball, what happened? The ball goes to the field. Let us take example when a batsman hit the ball, the bowler catches the ball, right? What happened? So in general, bowlers catches the ball like pulling it to the away. Why can't he catch like this? If he catch like this, he get hurt more. If he catch like this, if he pull the ball longer time, he get hurt less. Which means what? So he's increasing the time to decrease the force. In this case, the force is higher, time is shorter. As you increase the time, the force decreases, you get lower. You amount of force applied on you less. Right? I hope you understand this concept, impulse. This is a very interesting topic too. I mean, you have a lot of applications too. Now the question is, what is this actually? Impulse is nothing but change in momentum. Impulse is nothing but changing momentum. dp, what is this? This is nothing but change in momentum. So when you apply the force, there is a change in the system, right? So the dimensional formula is same. I'm going to talk about that lesson later. I mean, I think I have given that lesson before. So I'll talk about that dimensional formulas one class. So impulse dimensional formula is nothing but momentum. Okay. So now we completed this. So we talk about the force, linear momentum, impulse, and their example application day-to-day life. Now, and also we completed two laws: law of inertia, first law of Newton, and the second law, which always talk about the force. Then moving into the third law. What is third law? Third law is always talk about the for any action, for any action, okay, for any action, there is a equal and opposite reaction. For any reaction you take in the universe, there is a equal and opposite reaction should be there. So that is a statement of third law. Did you understand, guys? Action, reaction, these two terms, new terms. I mean, we know that action is nothing but also you're applying the force. Reaction is nothing but the duster. You can take about this duster. I'm applying force on the duster. The duster also applying force on you, and this is called reaction force. The force which you are applying on the duster is the action force. And these two forces are pairs, action reaction pairs. The force always in a pair forms. It's not a single, right? The force pairs are the force is always in the pair, action and reaction, right? Do they act in a single surface? The force, the action and reaction forces, they do not act on a same surface. They act. See, the duster is applying on a you, and the surface of hand, you're applying force on the duster. Two different surfaces. It's not a common surface. So they don't cancel. You can think they are equal. Action force, reaction force, both are equal. They are in a pair form, right? They are in a pair form. They are equal. They are opposite direction. They should cancel, right? But they are acting in two different surfaces, so they don't cancel each other. F1 or FAB, you can think about it, right? Is equals to minus FBA, right? So FAB equal to F minus BA, which means they are in opposite direction. They are equal, right? So when they don't cancel each other. Okay. So this is about Newton's third law. Then, so this is the basic laws of physics. So I think you understand these laws now. Newton's laws, especially you should understand very well. First law always talk about the. So let me summarize today class. I'm going to close this class in 2 minutes. So let me talk about. Let me summarize this class. So basically, the entire physics, the entire mechanics, Newtonian mechanics, always you should know these three laws, right? The first law is basically it always talk about the inertia. The mass is the measure of inertia, right? And the first law again, you should always, whether the object is motion or rest, whether it's changing direction, you should know all this stuff. And also, you're going to talk about after this free body diagram. That's also that play very important role. Free body diagram. What is the free body diagram? And then we go for the second law. Second law always, basically, it talk about the force. What are the forces exist in the universe? What is the force actually? Or how it produced? All this stuff related to the force. And the force also linked with the linear momentum. What is the linear momentum? How it helps. What is the conservation of linear momentum, right? So if the force is zero on the system, if the external force is zero, so basically what happened? So the system remains same, momentum doesn't change, right? Then we talk about the impulse. So what is impulse? Kind of force, but it always talk about the time versus force. It's a product of force and time. And conservation of linear momentum is also very important concept, because when you are dealing with the uh, bullet gun problems, you should definitely need to know this. What is the net momentum is zero? What is the net? When the force is zero, what happens? When two particles collide each other, what happened? What happened in elastic and elastic cases? Which physical quantity conserved? We're going to talk about the collision topic later. What is the free body diagram? What are the forces acting on the system? All these topic we're going to talk next class. I hope you understand this concept. But physics such a subject. You can first thing you have to feel it and apply this laws to your day-to-day life. Then you enjoy the physics like anything. Whatever the concept, whatever when you go walking, you think rubbing, everything, it requires the physics. I mean, such a lovely subject. Once you taste the physics, sweetness of physics. I mean, when we eat the sweet, how do you feel it? We eat more, right? Same thing, when you really understand the basics, you love, I mean, like, eating more laddus, like you also want to hear more about physics. What happened next? What happened next? Really, I mean, it's really great. I mean, get to know that what is going on, how it handle all this topic. I mean, very interesting. Everything is physics. Even if you go biology, even if you chemistry, mathematics, everything is a physics. So such a lovely subject. I mean, if you, I mean, this is the one, physics is the one. I mean, you can handle any subject. If you really understand the basics of physics, you can attack any sort of problems. I mean, don't start problems first. You have to understand concept, and you have to know what is given in the problem, what is the situation, which formula you have to apply. All these things you have to analyze first. If you immediately start problem, then you can't enjoy this subject is such a great, first you have to digest the loss, and then you go for the problems. So my suggestion to all students, those who are preparing IIT NEET, first you need to understand concept, read the textbook thoroughly, understand concept, then apply the concept on the problem. Then you can able to solve any type of problem. Okay. So thank you. Have a nice day.